Hello, my dear students. Let's start today's topics on aldol condensation. Listen, aldehydes and ketones having alpha hydrogen atoms only undergo aldol condensation. During this reaction, if you take aldehydes, two molecules or aldehydes are used. If you take ketone, then also two molecules of ketones are used. The reaction occurs in presence of dilute alkaline mediums such as dilute sodium hydroxide, calcium hydroxide. You can take barium hydroxide in dilute solution also. So, do you know what are alpha hydrogen atoms considering aldehydes and ketones? Just consider the aldehyde group carbon. The adjacent carbon of aldehyde group carbon is called alpha carbon. If the alpha carbon contains hydrogen atoms, that are called alpha hydrogen atoms. If you consider ketone, C double bonded O, the carbon of keto group, consider it the adjacent carbon of the keto carbon. If contains hydrogen atoms, called alpha hydrogen atoms. So, try to understand the alpha hydrogen atoms of aldehydes and ketones. This is acetaldehyde. The carbon belongs to functional group carbon. The adjacent carbon is called alpha carbon. And the hydrogens attached to alpha carbon are called alpha hydrogen atoms. Can you tell me, this is formaldehyde? Can you tell me whether formaldehyde contains alpha hydrogen or not? I know you say, yes sir, only one alpha hydrogen atom, but this compound has no alpha hydrogen atoms because there must be alpha carbon atom. Formaldehyde has no alpha carbon atom, so it has no alpha hydrogen atoms. This is acetone. Acetone has 6 alpha carbon, 2 alpha carbon and 6 alpha hydrogen atoms. So it undergoes aldol condensation. It undergoes aldol condensation. This is acetaldehyde, you know that. Acetone also undergoes aldol condensation. Formaldehyde has no alpha carbon, so there is no question of alpha hydrogen, so does not. This is benzaldehyde. Benzaldehyde has alpha carbon but no hydrogen atoms. This is benzene ring actually. If you draw benzene ring, so the carbon attached to the carbon of aldehyde group already tetravalent. 1, 2, 3, 4. So it has, this carbon has no alpha hydrogen. That's why benzaldehyde does not undergo aldol condensation. So remember it, those aldehydes and ketones having alpha hydrogen atom only undergoes aldol condensation. Okay. During aldol condensation, always two molecules are used. If you take aldehyde or ketone, you should take two molecules. Aldol is not a name of scientist, it is a name of condensation product. The reaction occurs in presence of dilute alkalis. You can take sodium hydroxide, potassium hydroxide, barium hydroxide, etc. Okay. So let's check the reaction. With acetaldehyde and dilute sodium hydroxide. Listen the technique. In aldol condensation, whether you take aldehyde or ketone, two molecules are used. So the technique is that write the structure of the first molecule. Whenever you write the second molecule, separately write one alpha hydrogen atom. See, three alpha hydrogen atoms are here. Write one alpha hydrogen atom separately. As oxygen is more electronegative than carbon, so oxygen attracts one bonding electron from carbon. The hydrogen atom gets attached to the oxygen and the carbon will attach to this carbon atom. So the product is double bond changes to single bond. Write it straight away, okay, so that you can write easily its IUPAC name. This compound contains aldehyde group and also alcoholic group. That's why it's called aldol. It's a condensation product. Aldol is not the name of any scientist. This is up to class 12 standard. But in entrance, further stepping is there. If the aldol which is formed is heated, one molecule of water is eliminated, one molecule of water is removed. So you get a condensation, a product, very important for entrance. Okay, I will write here. See the product here. one hydrogen is removed from here. This type of compound is called so this is the entrance question you get. Alpha beta unsaturated aldehyde. This is a type. It has some name. Called crotonaldehyde. Clear? So listen, in board exam, if only aldol condensation will come, so don't write this heating step, only write. If it is mentioned that what happens when aldol is heated, then also only write. Actually this is entrance based question. Now mechanism of aldol condensation is very important. Why? Because during aldol condensation, one intermediate is formed that is called carb anion or enolate ion, which is stabilized by tautomerism. During any reaction, if any intermediate is formed, here the intermediate is carb anion. You know carbon having negative charge called carb anion. If any intermediate undergoes resonance or tautomerism, then it becomes stable, which indicates that the intermediate is formed. So let's understand the mechanism of the reaction. Remember it, during aldol condensation, two molecules of aldehydes or ketones are used. In first step, the intermediate carb anion is formed. At first, take only one molecule of aldehyde, acetaldehyde. Write one alpha hydrogen atom separately as I have told you earlier. Sodium hydroxide is basic in nature, so it releases hydroxyl ion. It's a base. So remember it, base always attracts a proton. This is intermediate called carb anion or enolate ion. It is stabilized by tautomerism, that's why it is stable and it has some life. In step 2, this carb anion gets attached with another molecule of acetaldehyde. oxygen is more electronegative than carbon, so oxygen attracts one pi bond from carbon. This anion gets hydrogen from water. Because the reaction takes place in dilute medium, that is in presence of water. So the final product is this compound contains aldehyde group as well as alcohol group. That's why it is called aldol. I think you understand it. Acetone also undergoes aldol condensation. But using of barium hydroxide is preferable in case of acetone, because if you use sodium hydroxide or potassium hydroxide, you get the product. But using barium hydroxide is more preferable in industry. That's why see the reaction with acetone. I have already told you, during this reaction aldehydes or ketones having alpha hydrogen atoms are used. Two molecules are used. Draw the first structure of the molecules as normal. But whenever you want to write the second molecules, just write only one alpha hydrogen atom separately. That's the technique. So see the reaction of acetone in presence of dilute barium hydroxide. This is another example of aldol condensation, and we get a product called diacetone alcohol. Whenever the product is heated, that is diacetone alcohol, then what happens? This is not aldol. This is a similar product of aldol. That's why this is also an example of aldol condensation. Its name is diacetone alcohol. When this compound is heated, it releases one molecule of water. OH from this carbon, hydrogen from this carbon. So elimination reaction takes place and one bond will form here, extra bond. That is, a single bond becomes double bond. This compound is called mesithyl oxide. That is very important for entrance. I think you understand it. This is very important for entrance. Okay. Now the next topics, that is crossed aldol condensation. In this reaction, one molecule of aldehyde having alpha hydrogen, one molecule of ketone having alpha hydrogen are used. This is a similar type of condensation like aldol, but here 4 different types of products are formed. 2 are self-condensed product and 2 are crossed. Okay. Now see the reaction, that's called crossed aldol condensation. So you know that during crossed aldol condensation, 2 different compounds, that is aldehydes and ketones, are used, provided that both should have alpha hydrogen atoms. Let's take an example between acetaldehyde and acetone. You know that both acetaldehyde and acetone contain alpha hydrogen atom. So what is the technique? You get 4 different types of product. I have already written on board. 2 by self condensation, which you have done earlier during aldol condensation, and 2 crossed aldol condensation. But remember it, whenever you write the aldol condensation, follow the techniques. First molecule, draw as it is structure. For second molecule, write only one alpha hydrogen atom separately. That's the technique. So understand it. Between 2 molecules of acetaldehyde, Second example, between two molecules of acetone. You know that during IPC name, when there are different substituents, write their name in alphabetical order. These two are the examples of self-condensation. Now, cross-condensed product between one molecule of acetaldehyde and one molecule of acetone. You know that the first molecule, write the normal structure. For second molecule, write one alpha hydrogen atom separately. Okay. Now let's understand. First molecule, write the normal structure. Write one alpha hydrogen atom separately. Now the second crossed condensation product, just reverse, that is between one molecule of acetone and one molecule of acetaldehyde. This is acetone, this is acetaldehyde. Whenever you draw the first compound, draw the normal structure. For second compound, write one alpha hydrogen atom separately. That's the technique. Three hydroxy, 3 methyl, methane, ethane, propane, butane, but, 1 al. So these are the examples of crossed aldol condensation. There are another type of aldol condensation is there, that's called Glycine-Smith condensation. Actually, I have seen questions in entrance from Glycine-Smith condensation, and there is another type of aldol condensation that's called self-aldol condensation. That is the very important for entrance, self-aldol condensation. So when I will upload entrance classes, I will discuss the two reactions. One is Glycine-Smith condensation and another is self-aldol condensation. Okay. So thank you for watching. Please see my next video on Cannizzaro reactions, self-Cannizzaro reaction, mechanism of Cannizzaro reaction, etc. Okay, and applications of Cannizzaro reaction in entrance. Now, thank you for being with me. Thank you.